So today we have very interesting and very important topic to be get discussed. That is what we call it as the interfaces or interface we can say. Interface as it is the keyword, so I will use interface like this. Okay. So I can say about interface is that it is a blueprint. It is a blueprint of a class. It is a blueprint of a class. As blueprint itself says that it is not actual implementation. Okay, blueprint is like the thing will be like this one. Thing will be like this one. So that is what we call it as the blueprint. That is what we call it as the blueprint. That means that if like we are going to develop one organization, one company. Okay. Now before establishing that company, what we will do? We will design a blueprint of that company, that how it works, what are the products, what are the services, how the organization structure, so that everything will be get just documented. Okay, that is what we call it as the blueprint. Okay, so exactly same way what I said, interface is an blueprint of a class. Interface is an blueprint of a class. That means what? Simply here interface contains abstract methods. Interface contains abstract methods, and that methods will be get implemented by a class. That interface methods will be get implemented by a class, and hence in that scenario we call it as the interface is an blueprint of a class. Okay, so I can say in another word I can say interface is a collection of abstract methods. So that means what? Within an interface we are going to put a abstract methods in it. Okay, so I can say few things about that one. One, all methods of interface are by default abstract and public. By default, all methods are by default abstract and public. That means what? Whenever we are writing any method within an interface, we don't need to use abstract keyword as well as public keyword, because just yesterday we observed about abstract class. Okay, abstract class contains the abstract method, but while declaring the method as abstract, there we have used the abstract keyword. Okay, but here in interface all the methods are by default abstract. So in that case we don't need to use a abstract keyword. And again there is another thing, that all the methods are public. And hence we don't need to use even a public keyword. No doubt, since Java 8, since Java, we can say 8 feature. Since Java 8, we can have non-abstract method. We can have non-abstract method in interface. So that can be that is default method and static method can be added in the interfaces. So since Java 8, before Java 8, all the methods will be only abstract only. But since Java 8, methods can be default and methods can be static. And both the static method and the default method are the method with the body. That means what? These are the non-abstract method. These are the non-abstract method. Okay, then okay, that default method and the static method that we will see in the Java 8 feature. We will see that one in the Java 8 feature, so don't worry about that one now. Okay, if then very important thing about interface that we can't create a object of interface, like abstract class only. Okay, we can't create a object of interface, but we can create a reference variable reference variable or we can say variable of type interface we can say interface. So that is what we can say. So we can create object of interface. We can't create a object of interface, but we can create a reference variable of type interface. Okay, so that is what very important thing about this one. So here I can simply syntax for that one is interface. Here I can write the interface name. Okay, naming standard will be exactly similar to the class. Okay, so interface name, and here we can have abstract methods. Okay, then we can have default method that we will see later, default method. Okay, then we can have static method. We can have the static method, and about variable we can have final static variable. That can be putted within a interface. So that is what the very basic thing about the interface. For example, see here I am just going to create one interface. I can say interface operation, and in this interface operation I will put here simply one method, public or no need to put even the public and abstract keyword, so void. Okay, I just put the addition. Okay, and without the body I am putting this one, and exactly same way void. Okay, I just write a division. And this one is enough. Okay, so here I have created one interface with a name operation. Okay, and in that one I have put two abstract methods. Here you can observe I have not used abstract keyword, I have not used the public keyword. So by default methods of the interfaces are abstract and a public. Okay, but as we have created this interface, we can't create object of this one, or even when we create interface, memory is not allocated, because in this one nothing is there. Only the abstract method, that is method without the bodies, are there. So it is not useful until and unless we have not used that one. So how we have to use that? So we have to implement the interface by a class. So classes can implement interfaces. Classes can implement interfaces, I can say, by using by using implements keyword. Okay, so this is what I can say. So for example, see I have one class. Assume like this is what demo, I can say. I can give any name. So I just given here a demo, and I am putting implements and interface name. What is the interface name? Operation. I can just write here operation, and then I can do this one. I just finish this. So class demo implements operation. So this is how we can implement the interface. But there is the rule, very key rule, very important rule. When class is implementing the interface, interface, if class is implementing interface, it have to define, it have to, we can say define, or we can say implements, it have to define or implements all abstract methods in it, all abstract methods in it, we can say all abstract methods in it. Okay, so whatever the abstract methods of that one, we have to define. That means what? We have to provide the body. That is we have to provide body. We have to provide body to all abstract methods from interface we can say. So that is what the thing. So as I have written like this one, class demo implements operation, class demo implements operation. So as I'm writing like this one and I have not implemented any method, so on this line itself the compiler gives error. On this line itself a compiler gives error saying that if class is implementing the interface, okay, that have to define all the abstract method, otherwise class have to declare as, otherwise class have to declare as abstract, class have to declare as a abstract, we can say. So I don't want to declare my class as abstract, so I can define the methods over here. So I can write a public void addition. Okay, and here I will put addition logic. I will put a addition logic over here. Okay, exactly same way I will create another one method, public void division. Okay, and in that one it will provide the division logic like that. So in this way we can just implement all these methods. Now as we have implemented this one and we observe that we can't create object of interface, we can't create object of interface, but we can create the reference variable. So we can create the reference variable of the interface. So here I want to tell you very important another point is that reference variable of interface, reference variable of interface can refer, reference variable of interface can refer object of a class which implements interface, which implements the interface. That is what the important thing. If the class have not implemented the interface, its object will be not referred by the interface reference variable. Okay, so it is very important that reference variable of the interface can refer the object of a class which have implemented that particular interface only. Okay, so here in our case, like for example, I do have the operation ref is equals to, I can write a new and the class name is the demo, and through that one we can just go for ref dot addition, and exactly same way I can just write ref dot division like this one. So this is how we can invoke the method. So if we observe this one, it is simply the similarities like abstract classes. So interfaces and abstract classes are nearly same. We will go for that discussion, but it is exactly looking like that, and hence we can say why then why we go for this interface, why interface. So here reason to go for interface is one, to achieve 100% abstraction. To achieve 100% abstraction. So that is what here one case. Okay, second I can say it's used to achieve runtime polymorphism. Runtime polymorphism. Runtime polymorphism. So that is what the two reasons actually. That is what the two reasons we go for the interface. And one point we have discussed in the inheritance, that one class cannot extend more than one classes. So that is what the multiple inheritance is not possible in Java. But same multiple inheritance can be implemented by using interfaces, So these are the three reasons actually. These are the three reasons why we go for the interfaces. Okay, so how it is achieving the multiple inheritance, how it is going to achieve the runtime polymorphism or the abstraction, that we will go for that discussion. Okay, so this was the very basic discussion about the interfaces. So to understand this, I will just show you this through the programming. Okay, so that you guys can understand this. Okay, so I just close this. Why? Okay, it's taking time actually. So we have this one project. In that one, we can just go for the interface. So I can just create one package over here, new package, and in that one, com dot icons dot, okay, and interfaces demo. I'm just going to write over here. Just finish that. Okay, here I can just create a new interface. Okay, and here name of interface we observed, that is what the operation. Okay, in that I just finish this. It's taking time. Okay, so public interface operation, and in that one I'm just going to add the void addition. Okay, and here that is what the abstract method void division is like this. So I just return the division. I'm not interested in the logic. Okay, so I just given the names over here. So this is what the interface I have created. It is nearly like a class only. But all the methods are the abstract only. Now I will go for this implementation for this one. So just new class I will write. Name of the class is a demo. Okay, in that demo, I have not put anything here simply. I just want to implements. Okay, and name of interface is the operation. So as we have written like this one, see, it is giving the error. What error it is giving? The type demo must implement the inherited abstract methods from the operation. That is what the addition. Okay, that is what the division. It is showing the first one. So if a class is implementing the interface, compulsory that class have to define all the abstract methods in it. Okay, so what it is doing here, it is simply forcing the classes. It is simply forcing the classes to implement all the abstract methods in it. Okay, so I will just try to provide the implementation for that one. So public void, I can say simply addition. Okay, and in that, okay, I just write sys out. I don't know what happened today. Okay, it's getting very slow. Okay, so here, as we have written here, I can just say in addition of a demo. Okay, addition demo, and exactly same way. See, still it is giving the error. Okay, because now it is asking us to provide the division. Okay, so I can just shortcut way, I can just use here override void division. Okay, and there in that one I can write this out, and here in division, demo, like this one. So in this way we have written like this one. No need to use override annotation over here, as we have not discussed yet the annotation, but if we have written, it's okay. Okay, so what exactly meaning of that word we'll see later. So now see, public void addition and a public void division, like this one. Okay, so in this way we are trying to do this. Now I will go for the text test class. Okay, this is what the class test demo class. In that one I have put it the public static void main. Okay, and here if I try to create object of interface, here operation obj is equals to new, and I just put it operation like this. So if I written like this, operation obj is equal to new operation, it is giving the error, cannot instantiate the type. Because why? It is an interface. It is an interface, and interface cannot be instantiated. Interface cannot be instantiated, I can say. We can't create the object of that. Okay. But I can create the reference variable of it. So I just writing here operation ref. You can give any name, or not necessary, only the ref will be given. So I have given, you can give any name. So I just given ref, okay, semicolon, and then I can write ref is equals to new. Ref is equal to new, and name of the class is the demo, we can say. So in this way, we have given the reference of a demo object to the ref. And now by using this ref, we can just invoke the addition method. By using that ref, we can invoke the division method. You can see. Okay, I will just try to run this. Okay, and you can see in addition demo and in division demo, like this. So this is what a very simple way I can just say here. Now see, assume like this demo class can have its own method too. So assume I have created one more method, public void show method is there. Okay, and in that show method, I will put a very simple message over here. I will put a simple message here. In demo show method, like this one. Okay, this is what the very simple message. And now I am trying to invoke that method by using ref. I'm trying to by using this one ref.show, and you can see it is not available over there. That means what? Original methods of that particular class cannot be invoked by using the interface reference variable, even though it is referring that particular object. Okay, or in another word I can say interface reference variable. Using that we can invoke the methods of interface only, methods of the interface only. Other methods we cannot invoke, other methods we cannot invoke like this. Okay, then how you can invoke that? So for that one compulsory you guys have to create object of that class. So I can write a demo obj2 is equals to new, and here I just put it a demo. Okay, so here I created object of demo and I am calling like this one obj2 dot I can call addition, obj2 dot I can call division. Okay, by using this one I can write obj2 dot I can call the show method like this. So in this way we can call, in this way we can call, and you can see the output here. You can see the output. See, division demo is called twice by using reference and by using object of the demo. And here demo show is there, it can be invoked. Okay, then you might go have the question, sir, why we need this? Why we need this? Because even though by using the addition class of the, sorry, by using the demo class object we can invoke that one. So why we are doing this one? By doing this we have to write unnecessary this one code, unnecessary this one code. Here we are implementing like normal. Okay, and we are doing like this one. Okay, so here we call it as a static invocation is this one. Here static invocation is there. That means what? Here compiler will understand very easily that object is of a demo class, division is from the same class, so it will invoke the same version of that class, division and addition version. But by doing this one, compiler is not get aware about this. So ref.addition, ref.division. Here we are calling the division and addition method. Okay, by using ref, and ref is referring the demo, hence it is invoking the demo class version of that method. But if it is some other class referred by that reference variable, then that class version of the addition and the division will be get called. And that is what we call it as the dynamic polymorphism. That is what we call it as the runtime polymorphism. That is what we call it as the abstraction mechanism. So such a thing will be get achieved through the interfaces. Directly we can do, but it is what the static polymorphism. But if we have to go for the runtime polymorphism, if we have to go for the abstraction mechanism, then we should always go for the interface, not for the class. And that is what exactly the difference you guys can see over here. Yes, clear guys? Getting what I'm saying here?
Yes, sir.
Okay. Okay. So this same thing I will let you understand through the other one example. Okay. I will add one more thing in this one. Okay. One more thing in this one. Okay. That why here actually one interface can be implemented by more than one class. One interface can be implemented by more than one class, we can say. That means what? Assume I do have another one class demo2. Okay, earlier we have created the demo only. Here I am creating the demo. Okay, and here I can simply write implements. Okay, implements, and here I will put operation. Okay, again here we have to define all the abstract methods of the operation. Okay, let me explain through the Eclipse over here. So I just go to the Eclipse one more time. Okay, I just create another one class over here. Okay, name of a class is a demo2. Demo2 will be there. Okay, and this demo2 will implements operation like this. Okay, again it is giving the error. So I just copy the methods from here. Okay, like this one, and I just go for this class, and you can see the errors will be get removed. Okay, no error over here. So, but while doing this one, I will just write here a demo 2, and here too I will write a demo 2. Okay, write this one, and I think I have not copied the bracket. So I just copy this. Okay, I will type this one. So class demo 2 implements the operation. That means what, my operation interface have been implemented by demo class as well as a demo 2 class. Demo 2 class. Now I will just go here. I will just go here. And now I will just same reference variable which I have been created over here. Same reference variable I have created here. Ref is equals to now new demo 2. I will write a new demo 2 like this one. And now by using that ref dot addition, same by using ref dot division. Okay, I'm writing like this one, and I just saved this. Okay, and you can see now by using this one, addition and a division version of demo 2 will be get called. Okay, demo 2 will be get called. You can see here. Okay, so here you can see demo addition demo 2, division demo 2 will be get called. Then I want to take your attention over here. Okay, observe the line number 13 and 14. Observe the line number 13 and 14 over here. Line number 13 and 14 and line number 9 and 10. Both are exactly same. Both are exactly same. Okay, so when we compile this code, compiler will think that it will invoke the methods of the ref type. That is what? Operation type. But no, we know that operation don't have the body. Okay, so compiler will not understand this call will goes where. This call will goes where. So, but when execution comes at the runtime, okay, this will invoke the demo. This is also invoke the demo. Okay, version of that method. And when a call comes to this one, it will goes to the demo 2 version of that particular method, and here too it will go to the demo 2 version of that particular method. Okay, even though these two statements and these two statements are looking exactly same, but it is invoking the different version of that particular method. Okay, and this invocation will be get decided at a runtime. How? Through the object reference. If it is having the reference of a demo class, it is invoking the demo version of that methods, and if it is taking the reference of demo 2 object, it is invoking the demo 2 version of that particular method. So this is what we call it as the runtime polymorphism. This is what we call it as the dynamic polymorphism. Okay, and even it is what the one way we call it as abstraction, because user don't know. User don't know this invocation, this call will goes to the which version of the method. Okay, so that is what the abstraction over here. So this is what how we are going to achieve the runtime polymorphism. This is how we are going to achieve the dynamic polymorphism over here as well as abstraction over here. Clear? Yes.
Oh, sir.
Okay.